if the derivative of the function is greater than 0 or it is positive, we can say it is an increasing function. We have observed the function y is equal to x cube curve. So it's an increasing curve and it is not changing as the value of x increasing. So then we say that it is a point of inflection. According to the definition of local minima, f of c should be less than f of x, but here we are getting f of c is greater than f of x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to revise the chapter Application of Derivative. So let's see the chapter-wise weightage for this chapter. Now here from this chapter, you can expect 1 mark from MCQ, 2 2-mark question and 1 3-mark question. Overall, 8 marks from the chapter Application of Derivative. So let's take few objective questions. In the form of an MCQ, we have the point of inflection of the function y is equal to x cube is. So here the options are given as 2, 8, 1, 1, 0, 0, minus 3, minus 27. So for the curve y is equal to x cube, the curve will be like this. Okay. So you take any point here. So the curve is increasing. So from at the point of inflection, the curve is not changing its sign here, so it is positive. So clearly at 0, 0 will be the point of inflection here. So next question we have here, the interval at which the function f of x is equal to sin x is strictly increasing. Options are given as 0, pi by 2, pi by 2, pi, 0, pi, none of this. So when we take a function as a sin x, we know that if the derivative of the function is greater than 0 or it is positive, we can say it is an increasing function. So clearly f of x is sin x, so f dash of x is cos x. So if I draw the curve for cos x, so we know that cos 0 is 1. If I take this as 1 and this is minus 1, and if I take this as pi by 2, so here, and if I take this as pi, so it goes like this, so minus 1 and somewhere here. So you can clearly see cos x is positive in the interval 0 to pi by 2. So therefore, the first option 0 to pi by 2 is the correct answer. Next. The absolute minimum value of the function f of x is equal to x cube in the interval minus 2, 2. So first let us find out what is f dash of x and its critical point. So we have 3x square. If I put f dash of x is equal to 0, then this implies x is equal to 0. So we are going to find out the value at f of 0. So f of 0 will be 0, and also we will find at the extreme points, that is f of minus 2, which is minus 2 cubed minus 8, and f of 2 is equal to 8. So clearly the options are given as 0, minus 4, minus 8 and 8. Minus 8 is the minimum value, and hence the absolute minimum value will be minus 8 at the point minus 2. Next. Let f of x be a continuous function at a critical point C if f dash of x does not change sign as x increases through C. So here we have observed the function y is equal to x cube curve. So it's an increasing curve and it is not changing as the value of x increasing. So then we say that it is a point of inflection. So here the options are given as point of local maxima, point of local minima, point of inflection, and none of this. So the correct option is C is the point of inflection. Next. The local minimum value of the function f of x is equal to 3 plus mod x. Now we know that x belongs to R here, and options are given as 0, minus 3, minus 1 and 3. We need to find out the minimum value of this function. So clearly we note that modulus of x is always greater than or equal to 0. If we add 3 on both sides, then 3 plus modulus x is greater than or equal to 3. Now clearly 3 plus modulus x is our f of x, and if you put x is equal to 0 here, this 3 can be written as f of 0 because f of 0 is equal to 3. Now clearly we have f of 0 is less than or equal to f of x. So according to the definition of local minima, if f of c is less than or equal to f of x, then f of c is the point of local minimum. So what is f of c here? That is f of 0 is equal to 3 is the local minimum value. Hence, option D is the correct answer. Next, 2 marks question. Find the rate of change of area of a circle with respect to radius when r is equal to 6 centimeter. We know that area of a circle is pi r square. We need to find the rate of change of area with respect to its radius. That means we need to derive a with respect to r. So therefore, here r will become a independent variable. So therefore, it is pi. Derivative of r square is 2r. Now the value of r is given as 6. If you substitute r is equal to 6 here, the answer is 12 pi. Since the length or the radius is given in centimeter, so it is centimeter square. So 12 pi centimeter square. Next, an edge of the variable cube is increasing at the rate of 3 centimeter per second. How fast the volume of the cube is increasing when the edge is 10 centimeter long? So here we are deriving the rate of change of the quantity with respect to time. That's why the rate of increasing the edge is given in the form of 3 centimeter per second. So if I consider A as the side of the cube, then change in A is given here, that is 3 centimeter per second. And we need to find out the change in volume, that is dV by dt, when A is equal to 10 centimeter. We know that the volume of cube is A cube. So if we derive this with respect to t, then A cube becomes 3A square into dA by dt. So if we substitute the value of A as 10 and dA by dt as 3, then it is 3 into 10 square into 3. So that is equal to 900 centimeter cube per second. Next question, find the local minimum value of the function minus modulus x plus 1 plus 3 for all x belongs to R. So let me consider here mod x plus 1 is always greater than or equal to 0. Now, if the sign changes, then clearly this is less than or equal to 0. Now, I will add 3 on both sides. So, minus mod x plus 1 plus 3 is less than or equal to 3. Now, clearly minus mod x plus 1 plus 3 is nothing but our f of x. Now, this 3, I will consider this as f of minus 1. If you put here f of minus 1 plus 1 plus 3, minus 1 plus 1 get cancels, we will get the value of 3. So instead of 3, I can write this f of minus 1. So clearly f of minus 1 is greater than or equal to f of x. According to the definition of local minima, f of c should be less than f of x. But here we are getting f of c is greater than f of x. That means here f has no minimum value. Next question. The total revenue received from the sale of X unit of a product is given by R of X is equal to 13X square plus 26 plus 15. Find the marginal revenue when X is equal to 7. So, X is the number of units. R of X, that means the total revenue function is given. We need to find out the marginal revenue. So, marginal revenue is nothing but the rate of change of total revenue with respect to the units. So, that means rate of change of total revenue with respect to units. So here X is units and R is revenue. So R function is given. We have to derive with respect to X. So then this will be 13 into 2X, which is 26X plus 26 plus 0. So this is 26X plus 26. Now they have given the value of X as 7. That is 26 into 7 plus 26. So this will be equal to 208 in terms of rupees. So let's look at the 3-mark question. Find the intervals in which the function f given by f of x is equal to 2x square minus 3x is strictly increasing, strictly decreasing. So we need to find out the intervals where the function is strictly increasing and strictly decreasing. So given the function f of x is equal to 2x square minus 3x. So to find the interval, we need to find the critical points where the derivative of the function is 0. So first let us find f dash of x. So then it is 4x minus 3. If we put f dash of x is equal to 0, so this implies 4x minus 3 is equal to 0. So which implies x is equal to 3 by 4. So clearly we can divide the number line from minus infinity to plus infinity. So we have 3 by 4. So here we can take the intervals here and check the sign of f dash of x. And we can define the nature of f. So remember, this is sign of f dash of x and this is nature of f. So we can write the interval minus infinity to plus 3 by 4. So if you observe the extreme values, this is minus and another one is plus. So minus into plus will be minus. So that means here f dash of x is less than 0. So here the function is decreasing. To check this, you can take any examples between minus infinity to 3 by 4. For instance, you can take 3 by 8 there and check the value of f there. Next, we have the interval from 3, 4 to infinity. So here both are positive. So this implies f dash of x is greater than 0. So therefore in this interval it is increasing. So take any value greater than 3 by 4 and substitute in f dash of x. So if you substitute in f dash of x, it is greater than 0 there. So obviously f will be increasing in that interval. Next, find the intervals in which the function f of x given by f of x is equal to x square minus 4x plus 6 is strictly increasing, strictly decreasing. So we have a function here, f of x is equal to x square minus 4x plus 6. So f dash of x will be 2x minus 4. So if we put f dash of x is equal to 0, then that implies 2x minus 4 is equal to 0, which implies x is equal to 2. So again we can divide the number line from minus infinity to plus infinity. So one interval can be taken in the form of minus infinity, 2, and another interval can be taken in the form of 2, infinity. Now take any value between minus infinity to 2. For instance, take it as 1. Then substitute in f dash of x. F dash of 1 means 2 into 1, 2 minus 4, which is minus 2. So obviously f dash of x is less than 0. So clearly here f is decreasing. Next, take any value from 2, infinity. So take 3. For instance, 3, 2 3s are 6, 6 minus 4 is 2. So here f dash of x is greater than 0. So clearly here f is increasing. So thus we have found the intervals where it is increasing as well as decreasing. So here this is the interval. So sign of f dash of x. And here we have nature of f. So whether f is decreasing or increasing in the given interval. Next. A stone is dropped into a quiet lake and waves moves in circle at the speed of 4 cm per second. At the instant when the radius of the circular wave is 10 cm, how fast the enclosed area increasing? Now since the waves are moving in a circular form, the radius of the circle is changing. So, and it is given as 4 cm per second. So, therefore, dr by dt is given as 4 cm per second. Now, we need to find the change in area, that is dA by dt. So, when the radius r is 10 cm, when r is 10 cm. Now since we are deriving the area of a circle with respect to t, so we have dA by dt is equal to pi into 2r dr by dt. Now here we have pi 2 into 10 into 4. dr by dt is 4. So the value is 80 pi centimeter square per second. So this is the change in the area of the circular wave. Next, prove that the function given by f of x is equal to cos x is strictly decreasing in 0, pi, strictly increasing in pi, 2 pi. Now since the function is given as cos x, let's find its derivative, f dash of x. So that is equal to minus sin x. Now for the first one, f dash of x is minus sin x. Let's look at the sine curve. So this is 0, pi, 2 pi. Let me take this as 1, minus 1. So where the curve reaches maximum at pi by 2 and minimum at 3 pi by 2. So the curve is like this. So we can clearly see f of x is positive here. That f dash of x is positive here. So which is sin x. So here it is positive in the interval 0, pi. So it is minus. Sin x is positive there. So which will be minus. So that means f dash of x is less than 0. Clearly, if it is minus means it is less than 0. So therefore, clearly it is strictly decreasing in the interval 0, pi. Now let's check the second case. We have minus sin x. Let's observe the sin x in the interval pi to 2 pi. So this is the area. And this area is lying below the x-axis. That means it is negative. Our sine function is negative. So negative into negative will be plus. F dash of x is plus. What does that implies? F dash of x is greater than 0. So therefore here the function is strictly increasing in pi, 2 pi. Next question. Find two positive numbers whose sum is 24 and whose product is as large as possible. We need to find two numbers whose sum is 24. So let us consider the two numbers as x and y. So x plus y is equal to 24 and we need to show that the product is as large as possible. That means the product of this function attains maximum. So let us consider p is equal to x, y. Now from this, you can write y is equal to 24 minus x. So x into 24 minus x. So p is equal to 24x minus x square. Now let's find dp by dx. So that is 24 minus 2x. If we put dp by dx is equal to 0, then 24 minus 2x is equal to 0. So we will get x is equal to 12. Now let's show that it attains maximum. We'll derive d square p by dx square. So dp by dx is 24 minus 2x. If we derive this, we'll get the value as minus 2, which is less than 0. So when the second order derivative is less than 0, so this applies. Product is or product attains maxima. So that means the product of x and y is maximum when x is equal to 12. So therefore, x is equal to 12 and if you consider y as 24 minus x, the value of y is also 12. So in this session, we have revised the question based on applications of derivatives. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.